Question is an extract from just concluded 2023 NECO exam on chemistry. But the question said, consider the reaction represented by the equation. That is this equation: zinc reacting with hydrochloric acid to give us zinc chloride and hydrogen gas. So what volume of hydrogen in GMQ will be produced at STP when 2.60 gram of zinc reacts with excess hydrochloric acid? We have the relative atomic mass and molecular mass of some of the elements there, and then we have molar volume. We have the molar volume there, the molar volume, which is 22.4 dm³ for all gases at STP. So we want to find out, we want to look at this equation now. We say that the volume at STP. So what we're going to do here is that I will try to solve it in two different ways if possible, or perhaps the subsequent ones I will see how I'm going to solve them in different ways so that we'll be able to get it from different angles. So now when we look at this question, the first thing we do here is we consider the chemical equation. We look at the equation. The equation we have there is so from this equation now, looking at the equation, this equation has all the information you need in solving this problem. When you look at this, you find out that zinc, the mass of zinc that reacts with acid to give us hydrogen gas is, from this chemical equation, this mass here stands for what? 65 grams of what? Zinc. 65 grams of zinc. That is what's reacted with what? To give us the acid. I mean the, sorry, I said acid. Acid. For the love of acid. To give us hydrochloric acid again. To give us hydrogen gas. So at STP, we know that the hydrogen gas is 22.4 dm³. That is what we have at this, from looking at this chemical equation, which means this is a standard temperature. At standard temperature and pressure, what you will have is all these things, because it's what? At STP. So now this is what we have at standard environment when the temperature and pressure remain the same, when they are constant at STP. So now he said when we have this gram, what are we going to produce based on the same standard temperature and pressure? Based on the same standard temperature and pressure. So what we'll do now, that means 2.6 grams of zinc. What are we going to get from here? What we're going to get from here will then be 22.4 over 65 times 2.6 over 1. So what we divide through, we have 0.896 dm³, or we can say that when we round up this, we'll have it 0.90 dm³. That is what we have. So we are going to solve it again using another angle. But one thing is that personally, anytime I'm solving this question, I will make sure I follow whatever I'm giving here. Perhaps if the question is given to you, let's say in moles, then the system remains the same, the method of solving remains the same. you compare them, because we know that this other one will give us 1 mole, while this other one is what the same to 2.4 dm cube. So now what we do here is to convert this one to moles. If you convert to moles, everything will give you the same answer. So that is, it's very important that you consider whatever you are giving to know where you are, the method you are going to use in solving your problem. But then based on the one that is very easy for you, you can always try it the other way around. So let's look at we're going to be trying another question. We're going to look at another question here, and after that question perhaps we'll try one more. Here we have another question. Said calculate the volume in dm cube of carbon 4 oxide formed when 75 grams of calcium triazoxide carbonate is decomposed by heating. Now when calcium triazoxide carbonate 4 decomposed by heating to liberate carbon 4 oxide. So now before we solve this, in every stoichiometric calculations, balanced chemical equation is very necessary, like what I did in the other one. Balanced chemical equation will give you all the basic information you need whenever you're solving a question that has to do with what? Stoichiometry. So in this question now, the first thing we do here is to get a balanced chemical equation. The balanced chemical equation of this is so this balanced chemical equation will give you a picture of everything that you are expected to do. So looking at this, you can see that 1 mole of calcium triazoxide carbonate will liberate 1 mole of calcium oxide, and also liberate 1 mole of carbon 4 oxide. Now another thing is that the molar mass of this, or relative atomic mass of that of this one we have here is also, we know we have calcium is 40 plus carbon, which is 12, plus the other one we have 3 bracket 16. That will give us 48. So adding it up together, when you add it up together, you have 100 grams. Let's say it's 100 grams. So this 100 grams is what we have. We have 100 grams of this. Now, the basic things we are doing here now, the question is based on calcium triazoxide carbonate 4 and what? Carbon 4 gas. So since that is what we need, we know that 1 mole of this is also equal to 100 grams of what? Calcium triazoxide carbonate 4. 1 mole of this at STP, carbon 4 oxide at STP, is also equal to what? It says equal to 22.4 dm cube. That's what we have based on the Avogadro's law. So yes, 100 grams will give us 22.4 dm cube of what? Carbon 4. So now, what will 75 grams of this give us? We'll then say over what? 100 times over 1. So when we multiply through, by multiplying through now, what we will get here will be, we're going to get, we have 16.8 dm cube of the what? Of the gas carbon 4. Now, if we want to work in moles, like I said in the other calculation, if you want to work in moles, if you convert this to moles, you say that this divided by mass, reactive mass over molar mass will give us the number of moles. Our number of moles will be something like this. So that is 0.75 moles. 0.75 moles. So what it means is that 1 mole of calcium triazocarbonate will liberate 22.4 dm cube of what? Carbon 4. So then 0.0.75 mole will then give us 22.4 divided by 1 times 0.75. That will give us the same thing as 16.8 dm cube. So based on this, you find out that all of them will be arrive at the same answer. They will give us the same answer. But one thing is that I personally always advise anybody that's solving this problem, any student or a candidate that's writing the exam, you always look at what you have so that it will look easier, to make the work easier for you. Because the question here says the mass, talking about mass, because it means that we are moving from what? Mass to volume, mass volume. That is what we're looking at here. Some of them might come in the form of mole volume, but since it's mass volume, I will always encourage you, advise you to stick to this than this, except where perhaps where you're giving a calculation that has to do with moles. Maybe they ask you to use moles, they can use it. But in a case where you have a question like this, everything is in mass, don't try to run through it, because this looks like a longer process while this other one looks a bit easier. So we're going to be looking at another one question. Don't go away. Here we are asked to find the volume. Say that what volume of dm cube of carbon of oxygen at STP is required to convert 60 grams of carbon 4 completely into carbon 60 grams of carbon completely into carbon 4. So what we do here, like I stated earlier on, you need to write a balanced chemical equation of the reaction. In a balanced chemical equation of the reaction, so this is what we have. Since we have this, it means that 1 mole, 1 mole, and 1 mole. So now we have in grams. We know that this one is what? Is 12. So it's 12 grams will give us 22 point. We require what? 22.4 dm cube. Also, we can say 22.4 liter. So, but let's maintain what is given to us here. So the next one is that we'll go back to this. Why do I choose to do this? Because this is a standard condition. This is a standard condition. That's why I choose this volume. This is the standard volume at STP. This is the volume of every the molecular mass or atomic mass of carbon. So relative atomic mass of carbon. This is what we have here. So so now we are going back to what we have here. What do we have? We say we have 60 grams. This 60 grams, we say 60 grams of carbon will give us this will give us 112 dm cube of what? Oxygen. So we need 112 dm cube of oxygen to convert this completely towards 60 grams of carbon towards carbon 4. Thank you so much for coming this far, and I would like to read your comments, and I would like also to share. Your comment is very important to us, and then we want you to share and subscribe if you have not, so that you will be able to enjoy more from us. Thank you so much.